Hello, I'm Seema and welcome to part 2 of the topic Acids and Bases in Organic Chemistry. In the previous video, I told you about the various definitions of acids and bases. In this video, we are going to move on with the concept of acids and bases. We'll first carry on with our Gen Chem part and then come to the Orgo-Chem. This is the dissociation, the equation for the dissociation of an acid. HA is an acid and it dissociates to form H positive ions and A negative ions. It is the H positive ion which makes it acidic in nature, because we've studied the Arrhenius definition and the Laurie-Bronsted definition, which says that acids are proton donors. And when the acid donates the proton, what is left is the negative part, which is the base. Also, we studied that anything which is positive basically is an acid and anything which is negative would basically be a base. Now, if we have this equilibrium, and in the equilibrium we have the acid which is dissociating and the ions which it dissociates into, and the acid are in equilibrium, we can have the equilibrium constant here, which is the dissociation constant of the acid, which is known as Ka. And Ka numerically would be equal to the concentration of H positive ions into concentration of A negative ions divided by the concentration of the HA acid molecules. Now this gives us the value of Ka. And since the acidic character actually depends on the H positive ions, an acid would be a strong acid if it loses H positive ions easily, or the more H positive ions that it loses, the stronger is the acid. So basically, the acid strength does not depend on all of this. It actually depends only on the H positive. The A negative and HA are there in the equation, of course, but our main focus should be the H positive ion. So Ka is equal to this, the concentration is actually proportional to the H positive ion. So we say the value of Ka is proportional to the H positive ion, and therefore the value of Ka is taken as an indication of the acidic, or if it was Kb and it was a base giving us HOH, it would have been, AOH, it would have given us A positive, whatever the positive ion is, and OH negative. And the negative part, again, the base dissociation constant would have been Kb, and Kb would have been proportional to the OH negative, because in the case of a base, we would have been interested in the negative part, or the A negative in this case. So we find that Ka, since it's directly proportional to the concentration of H positive, then the higher the concentration of H positive, or the higher the value of Ka, the stronger would be an acid. And lower the value of H positive ions concentration, weaker would be the acid, or lower would be the value of Ka. So we say for high values of Ka, it means it's a strong acid, and for low values of Ka, indicates a weak acid. Usually the concentration of H positive ions, if you really see the kind of numbers that we deal with, would be to the concentration of 10 to the power minus 50, 10 to the power minus 20. Now these are strange numbers to use in calculations, in simple calculations. So a solution was found to this. Instead of dealing with concentrations which were 10 to the power minus 50, would it be not better if we used only the power, that is the 50 and the 20, if we handled only those numbers and not some exponents? So what was done? A new value was deduced from this, which was called the pKa. Alright, it was the pKa. pKa value is actually the negative log of Ka. It is the minus log of Ka. Why? If you find the log of Ka, let us say the value of Ka is 10 to the power minus 50. If you find log Ka, it would be minus 50. again you're handling negative values. We did, instead of having an exponential value, we now have only the power part that we have to compare. So the calculation is definitely easier. But the minus 50, the negative values, again, we would like to get rid of the negative. So we say the pKa is actually the log of Ka and the negative of that. So minus 50, the pKa, if Ka is 10 to the power minus 50, then pKa would be minus log Ka, so it would be 50, right? And so pKa value is actually, it is now, if a high value, 10 to the power minus 50 and 10 to the power minus 20, which is larger? 10 to the power minus 20 is larger. So the larger the value of Ka, the stronger is the acid. But the smaller the value of pKa, the stronger will be the acid. Here we saw this is larger, therefore this is the stronger acid. But the pKa values of these two would be 50 and 20. So the stronger acid remains the stronger acid. So the pKa value of this is smaller, that is 20, and the pKa value of this is 50. So the one which has smaller pKa value would actually be the stronger acid. So we say that the value of pKa is inversely proportional to the value of Ka. Right? So these are just basics that you've already done in your Gen Chem part. So this was how we handle numerically how strong an acid is. You're given the values of Ka or the pKa values, and then you have to compare these values and you come to know which is a stronger acid or which is a weaker acid. But in organic chemistry, you would be given molecules like this in your examination. Like this is ethanol, this is ethanoic acid, and this is ethanamine. Now, they'll just give you these molecules. They won't give you any Ka values, they won't give you any pKa values, and you'd be expected to answer which one out of these is a stronger or a weaker acid. So now if you do not have the Ka or pKa values, what are you expected to do? Has the person who has made the paper or the paper setter made a mistake by not giving you the values? No. He's not made a mistake. You are expected to look at the molecules and then judge on the basis of certain properties whether the molecule would be more acidic or less acidic. Would it be more basic or less basic? So for this, to be able to predict the acidic nature or the basic nature of organic molecules, we follow 5 steps. These 5 steps are, we use a mnemonic which is called CARIO. If you just remember the CARIO, what CARIO stands for, and you follow these 5 steps, you will be able to judge whether a substance is more acidic or less acidic just by looking at the molecules. What are CARIO? The C in CARIO stands for charge. You have to see the charge of both the acid and the base, the conjugate base. A stands for an atom which is holding that charge. The atom that holds that charge is A. R stands for resonance. I stands for inductive effect, and O stands for orbitals. You have to follow the steps CARIO. As soon as you look at the molecules, these are the steps that mentally you start following, and you start ruling out which one, or selecting which one is a stronger acid and which one is a weaker one on the basis of these points. So now we'll handle these points one by one. The first point here is charge. In the mnemonic CARIO, we are now going to start with the first step of judging. As soon as you get a question, you're supposed to look at the charge. And what charge are you supposed to look at? You're supposed to look at the charge of not only the acid, but also the conjugate base. Am I clear? So if you look at this equation again, the dissociation of the acid, Ha breaks down to form H positive and A negative. If the acid is strong, it means it dissociates easily into H positive and A negative ions. If it dissociates easily, it means the products that it forms, they should be stable. If the products that it forms are stable, it means the products are not reactive. Stability means being not reactive, and instability means being more reactive. So we find that when Ha dissociates into H positive and A negative, the H positive, all acids produce the H positive. So it's not H positive that we should be very concerned about. All acids will dissociate to give the H positive. It is this A negative that should be of interest to us. That is, and what is A negative? It is the conjugate base of the acid. If the conjugate base that is formed is stable, it would not like to go back and react with the H positive and would finally go and form the acid again. Rather, it would like to stay as A negative because it is more stable as A negative, and therefore, since it remains as A negative, H positive remains as a H positive, and therefore the acid is producing more H positive ions, and hence the acid is a stronger acid. On the other hand, if you have a weak acid, what happens? It dissociates. Why do we call an acid a weak acid? The acid dissociates to form H positive and A negative, but the A negative which is formed is not stable. The conjugate base is reactive, and if it is reactive, it is going to recombine with H positive and give us the acid back. And if it does, in the equilibrium, we find the reverse reaction is also fast enough to not allow much of a concentration of H positive. In the previous video, I told you a strong acid produces a weak conjugate base, and a weak acid produces a strong conjugate base. You can understand this clearly from this. When a strong acid is formed, the conjugate base is stable. Stable means it does not react. And since it is a base and it does not react, it means it is a weak base. So a strong acid produces a weak base, and a weak acid, on the other hand, when it dissociates a weak acid, it produces an unstable base. If the base is unstable, it means it is a reactive base, and a reactive base is nothing but a strong base. So when you have a weak acid, the weak acid produces a strong conjugate base, but a strong acid produces a weak conjugate base. So when you look at both of these, you should look at the charges of not only the acid but the base also. So that is the conjugate base. The more positive an acid is, we say whatever is more positive is acidic in nature, and whatever is more negative is basically basic in nature. So the more positive a substance is, the stronger is the acid, and the more negative something is, the more basic it should be. So when you look at the charges, what are you looking at? You're looking at the positive and the negative. The more positive charges it has, the stronger will be the acid. The more negative charges it has, the weaker would be the acid, or stronger would be the base. Now let us look at these three examples. H3O positive is the hydronium ion, H2O is water, and OH negative is the hydroxyl ion. If we compare these three species, which out of these, and we want to arrange them according to their acidic character, what are we supposed to see? We are now focusing on the charge. On the basis of charge, how do we tell which is an acid, which is a base, which is stronger, which is weaker? So if we write their structures like this, H3O positive is H2O in which one H positive has been added, and since H positive means there is no electron that it is bringing with it, therefore H3O has a positive charge on this oxygen. Now this pair, every oxygen has 6 electrons, right? So oxygen has 6 electrons, one lone pair, 2, 3, 4 and 5 and 6. It means oxygen is using both its electrons here to form the bond with H positive. Therefore, since oxygen is using both its electrons, the positive charge and the electrons are moving towards hydrogen here, the positive charge comes and concentrates on the oxygen. So in this species now, the central atom always has the 8 electrons around it. Remember the octet. So hydronium ion that is formed, it dissociates, and let us assume that all of them are dissociating to give out protons. And what would their conjugate bases be? Because we have to see the charge on the acid and charge on the conjugate base. If it dissociates, that is deprotonation occurs. Deprotonation is removal of a proton. Right? So dissociation of acid releases a proton. So on deprotonation, which I've shown by a negative H positive here. So when the H positive, you must notice that this red bond that I've shown is where the bond is breaking, and it is this hydrogen which is being removed. And while this hydrogen is being removed, the two electrons which are the red bond will be left behind, because H is not leaving as H atom, it is leaving as H positive. It means it is leaving behind the electron. So when hydrogen H positive is removed from here, these two, the red line becomes a lone pair of electrons. So you have H2O, and the lone pair of electrons forms water molecule. Water molecule is a neutral molecule, right? So what is the charge on it? The charge is 0. Now the next here is H2O. So when you have H2O, what do you see here? It is this bond, when protonation occurs, it is this bond which is breaking. So the H positive will leave, and these two electrons will form the lone pair of electrons over oxygen. So what will be left with? We have, once minus H positive leaves, you have these two electrons forming H, O, and the two electrons are shown by two dots. Oxygen originally has 6 electrons, and if it had 6 electrons, the 7th electron it gets from hydrogen, and 1 electron it has got from this hydrogen which has left. So this oxygen now has 8 electrons. One, it is formed, it had 6 electrons, but now has 8. One is a bonded electron. So this 1 electron is obtained from hydrogen, which is not involved in any bonding. Therefore, this makes oxygen negatively charged. And the charge it has is a single negative charge. One negative charge. Right? Now, this had a charge of 0. This has a charge of 1 negative. OH negative already has a negative charge. OH negative already has a negative charge on oxygen, and again this hydrogen is going to leave. When it leaves, oxygen has 8 electrons in its outermost shell, out of which 1 electron is, 1 negative charge was already there, and 1 negative charge it obtains from this hydrogen which leaves. Therefore it has 8 electrons around it, but the negative charge on oxygen now, this is an oxide ion. So oxide ion would have a charge of 2 negative. What did I say? The stronger, now this is H3O positive, this has a positive charge, right? This has 1 positive charge. This is neutral, and this has 1 negative charge, right? The 3 species here, 1 positive, 0, and 1 negative are the charges. We said look at the charges of both the acids and the conjugate bases. What are the charges of the bases here? This is 0, this is -1, which I have put here, and this is -2, right? And then how do we know which is a stronger acid? More positive is more acidic. So if you look at the acids, the more positive is H3O positive, would be more acidic, and the more negative would be more basic. So this is most acidic, H3O positive is most acidic, and OH negative would be least acidic. If you looked at the negative charges, that is the bases, in bases we say the more negative is more basic. So the more negative is more basic. So if this is more basic, this is more basic. Or we should say, out of these 3, this is the most basic. This is most basic, and this is least basic. Right? And here we said this is most acidic, and this is least acidic. Now, did you notice what I told you here? If you have a strong acid, out of these 3 examples itself you can notice, If we had the most acidic substance produced the weakest base, and the weakest acid produced the strongest base. So the first step in judging whether a substance is a strong acid or a weak base, or a weak acid, strong base, or a weak base, the first step is to find out the charge. And remember the mnemonic CARIO. We first notice the charge and judge which is more acidic or less acidic. And in case we are unable to reach a conclusion on the basis of charge, then we move on to the next step, that is the atom holding the charge. If we are unable to judge or we find similarity there also, then we move on to the next step, that is we notice resonance. If we are still unable to, we find that charge is the same, atom holding the charge is also the same, resonance is also the same, then we come to inductive effect. And if we find those are also similar, we move on to orbitals. So one by one, we follow these steps. So in the next video, we'll be dealing with atom holding the charge. If you found the video useful, please like it and subscribe to my channel and recommend it to your friends, and please keep returning for more videos in chemistry. Thank you and bye-bye.